In this video, we are going to discuss about dielectric breakdown, which is in the material science subject PH 8251. Course outcome. Upon completion of this course, the students will be able to interpret dielectric breakdown. Now let us see what are dielectric materials. Dielectrics are the materials in which all the electrons are tightly bounded to their parent molecule. Therefore, they have no free electrons. All dielectrics are insulators, but they are slightly differs from insulators because the dielectrics are used to store electrical energy. The example for dielectric materials: glass, mica, rubber, paper, wood, ceramics, ebonite, etc. Now we have the question. So what is the difference between insulators and conducting materials? In both the materials, electrons are available, but the conducting materials such as metals can conduct more heat or electricity than the insulating materials. The insulators are also having electrons. The conducting materials are also having electrons. But the insulators are not able to conduct heat or electricity. That is the difference between these two. Because in the conducting materials such as metals, the number of free electrons will be more. But in the case of insulators or dielectric materials, there will be no such free electrons. Therefore, they cannot conduct heat or electricity. So now let us see what are these free electrons. So the free electrons are nothing but the electrons available in the outermost incomplete orbit of an atom. If the number of free electrons are more, the conductivity of the materials, particularly the metals, will be more. If the number of free electrons will be less, the conductivity of the material will also be less. This is the basic concept of the conducting materials and the insulators. Here insulators are nothing but dielectrics. Now let us see what is dielectric breakdown. We know that the dielectric materials are not able to conduct heat or electricity. Here we have to see what is dielectric breakdown. That means simply we can say, in some circumstances, the dielectric materials will lose its insulation property and suddenly becomes conducting materials. This phenomenon is called as the dielectric breakdown. Now let us see what is dielectric breakdown. When a dielectric material is placed in an electrical field and when the field exceeds the critical field value, the dielectric loses its insulation property and becomes conductor. This phenomenon is known as dielectric breakdown. Now let us see the different types of dielectric breakdown. The first one, intrinsic or avalanche breakdown. The second one, thermal breakdown. Third one, chemical breakdown. Fourth one, discharge breakdown. And the last one, defect breakdown. First let us see what is intrinsic or avalanche breakdown. When a dielectric material is subjected to electric field then the electrons in the valence band acquire sufficient energy and move to the conduction band by crossing the energy gap and hence become conduction electrons. Therefore, large current flows through the dielectric and changed into conductor. This breakdown is called intrinsic or avalanche breakdown. So this picture clearly shows the intrinsic breakdown. We know that there are two important bonds. The first band is the valence band, that is the bottom band, and the upper band is nothing but the conduction band. The gap between these two bands is called the forbidden band or energy gap. Since few electrons are available in the valence band of a dielectric, when huge quantity of current is applied to this dielectric material, these few valence electrons will move from the valence band to the conduction band through the energy gap. As a result, when the electrons are moving from the valence band to the conduction band, the material starts conducting. So the dielectric will lose its insulation property and it becomes the conductor. So this is called as a intrinsic breakdown. The second breakdown is thermal breakdown. Thermal means heat. When a dielectric is subjected to an electrical field, heat is generated. It is an usual one. The generated heat is dissipated by the dielectric. But in some cases, the heat generated will be very high compared to the heat dissipated. Dissipation means the heat will be emitted in any way from the material to the surroundings. When such heat is dissipated in a huge quantity, under such conditions, the temperature inside the dielectric increases, which results in local melting of the dielectric material. Once melting starts, that particular region starts conducting in the dielectric material, whatever the area may be. So the enormous quantity of current flows through the material and the dielectric breakdown occurs. That means the area which starts melting, conducting the electricity or heat, that is due to the heat developed inside the dielectric material. Therefore, this type of breakdown is called as the thermal breakdown. Now let us see the figure of thermal breakdown. Here we have to consider the dielectric material, dielectric capacitor. When huge quantity of current is flowing through this dielectric material, it starts melting. As a result, it will start conducting. The third breakdown is chemical and electrochemical breakdown. So this type of breakdown is almost similar to that thermal breakdown. If the temperature increases, mobility of the ions will also increase. Mobility means the speed of the electrons or the ions. When mobility increases, leakage current also increases, and hence the electrochemical reaction may be induced. Due to this chemical reaction, the dielectric loses its insulation property and becomes conductor. Now let us see the figure. Suppose when a dielectric material is used in some chemical reactions. Due to the chemical reaction effect, sometimes the mobility of ions in the dielectric material will be increased, so that its energy will be increased. As a result, the dielectric material starts conducting because of the decrease in the insulation property of the dielectric material. This type of breakdown is called as the chemical breakdown. Now let us see the discharge breakdown. In some dielectrics, occluded gas bubbles may present. Occluded means very dirty gas bubbles. When these dielectrics are subjected to electric field, the gas present in the bubbles will be easily ionized and hence produce large ionization current, and the breakdown will take place. This type of breakdown is known as discharge breakdown. This is mainly occurred during manufacturing of the dielectric materials, so that sometimes due to this gas bubbles, the dielectric material may conduct electricity or heat. Now let us see the last breakdown, that is defect breakdown. Some dielectric have defects such as cracks, pores and small holes, etc. All these will occur at the time of manufacturing, unfortunately. These vacant positions may have moisture or impurities, which leads to breakdown known as defect breakdown. Suppose a small quantity of moisture or dirty particles present in this small hole or cracks. When the electricity is passed through this insulating material, sometimes due to this moisture, the dielectric material will lose its insulation property and becomes conductor. So the breakdown due to these defects present in the material is called as the defect breakdown. So in this video, we have clearly discussed about the dielectric materials and the different types of dielectric breakdown mechanisms. Thank you.